it's no big deal. Just log out and log back in using that link that I emailed you. So thanks everybody for coming to NACHI TV, where we do free webinars for home inspectors. We do 1 or 2 every month, and this webinar is all about inspecting a gas furnace. And we're gonna do probably an hour or 2 in-depth an inspection process on how to inspect a gas furnace. And I wanna share how I inspect a gas furnace. We're gonna go over a step-by-step checklist. It may differ from what you do. What we're gonna go over is the basic inspection checklist, and some of the tasks involved go way beyond the standards of practice. So you don't have to exceed the standards of practice, but we'll talk about that in a bit. So if you go to NACHI TV, NACHI.TV, that's where you can register for a free live interactive webinar. And if you're in class right now, you can ask questions, talk to other inspectors, and interact. And I'll try to get to the questions, but I'm not too sure if I can. It's going to be a good long webinar. So grab your coffee and let's see how this goes. All right. Oh, everyone who registers for a NACHI TV webinar receives the video recording. So if you have an inspection coming up, if the business phone rings, answer it and go. I'll email you a link to the video recording. Everyone who registers for a NACHI TV webinar receives a video recording, so you can watch it later. We had almost 650 inspectors register for today's webinar. And while I have you all, NACHI hosts an annual home inspector convention in various parts of the country every year. Last year we were in Colorado. We had a fair, an inspector fair at a county grounds. The year before that we were in Atlantic City. Upcoming in October 15 to 17 in 2020, we're in beautiful, sunny Southern California. And it's at a huge, big convention building. It is massive. It's going to hold probably 1,000 inspectors. We have lots of vendors and a ton of exhibitors and workshops and presenters. And the workshops are taught by certified master inspectors and experts in the industry. They're not salesmen, right? So you're not going to be pushed at the end of the presentation. Here's a thing that I wanted to sell you about. It's all about really good, excellent training, business, ancillary inspections, marketing, and advanced inspection techniques. And right now we have a ton of exhibitors, and they're all giving away stuff for all of the attendees. And right now we have, looks like 2 so far, really good giveaways, a lifetime NACHI membership, and a $1,000 infrared camera. So register now. I think it's about 150 bucks or something for early bird registration. And if I was planning on going somewhere warm in October, it's about 87 degrees in Southern California where we're going to have the convention. So it's a really nice place and a ton of other things to do around in that area. So you can take your friends, family, spouse, significant others and have lots of fun and get really good training and bump elbows with about 1,000 other home inspectors and the best vendors in the industry. And that's at, let me type the URL, that's at nachi.org, nachi.org/convention if you wanted to register or get details about the upcoming National Home Inspector Convention. But you're right now on NACHI TV, nachi.tv. There's a big button to register for a webinar and watch the most recent webinar. If you scroll down, there's all these topics and categories. You can click that if you wanted to watch a video recording of a marketing webinar that we did recently. Let's inspect a gas furnace using an inspection checklist. And this is on a nachi.org page. It's on our checklist page. If you wanted to download this information yourself, you can simply email me, and I'm going to type my email address for those who are watching. Ben at internachi.org. Ben at internachi.org. Email me. I'll send you the link to the checklist, and you can download it as a Word document, so you can customize it yourself, or as a PDF. You can print it out and study it that way. But this is a basic inspection checklist, an inspection procedure, step-by-step tasks on what you could do during an inspection of a gas furnace during a home inspection. We're going to assume you're doing a home inspection. This is the furnace section or heating system section. So what I do as a home inspector is I do the roof before my client shows up, and then I do the exterior as my client is there, and I may take him around, and then I go inside, pop my outdoor shoes off and put my indoor shoes on, and grab my toolbox. I take a look as I pass maybe the living room or dining room to look at the thermostat location and then the type of the thermostat. And in my area, we had basement, so I go down in the basement to get to the heating system. Maybe you're not in an area where there's basements, so you would find the utility room. And then you'd start your inspection checklist. Why would you have an inspection checklist as a download? So that you can incorporate it into your software, right? So let's see here. Let's see if I can be really fancy. And I'm showing people my phone. See if I can get this to go here. Oh, yep. Pull it over. Okay, so you folks who are watching, who are attending the webinar live or watching a recorded video, I just brought up my iPhone, and it's a mobile device, and I have software on it. And it's the best way to perform an inspection because, well, the advantage of bringing a mobile device while you're inspecting something difficult like a heating system, it makes you look smart because you know what to do. You can put the step-by-step checklist on your mobile device, right? And also it helps reduce liability and making mistakes because you have the checklist in front of you. You can't possibly forget to do something when you have the checklist in front of your face, right? And it speeds up the whole inspection process anyways. You can take pictures and videos and write the report as you inspect. So what I would do is I would go to the heating section. So I'm clicking on my phone, my software opens up, and at the top of my software that I use, there's little reminders, and you can customize these reminders. And in here, you can customize this one, and it's a good place to put the checklist that we're going to go over, just to remind you what to check, and you can customize it again. So the basic standards of practice, there's several things, handful of things that are required by a home inspector to check according to the home inspection standards of practice. But if you wanted to go a little bit further and do a more thorough inspection or do something that is benefiting your client or exceeding the standards of practice a bit, what do? Well, you bring your checklist with you. So that's an advantage of downloading the InterNACHI checklist for performing an inspection of a gas furnace. And I would click here and I would identify that it's a gas furnace. It's a warm air heating system. Here's some limitations. Let's say the heating system is inaccessible, and then the filter is dirty. That's a defect, and I've got some corrosion and rust, yada, yada, right? So I'm writing the report as I inspect, and I look really smart, and I'm reducing mistakes. So there's a huge benefit of having a good checklist that you can refer to and incorporate into your software. And that's what InterNACHI provides. We've got a ton of checklists for you. We also have a standards of practice. So according to the InterNACHI Home Inspection Standards of Practice, home inspectors are required to inspect the heating system using normal operating controls. The inspector shall describe the location of the thermostat. Remember when I came into the house, I try to look and determine where that is and keep it in my head and put it in my software. The energy source, is it? Coal-fired, wood, pellet, stove, gas, natural gas, propane, and the heating method. Does it blow air around, or is it electric? Something like that. An inspector shall inspect readily accessible and visible portions of the chimney connected to the heating system where applicable. The inspector shall report as in need of correction any system that didn't operate, and if the system was deemed inaccessible. So terminology is really important when you're observing systems and components of a home, seeing how they work, and writing your observations down in a report, maybe with recommendations to correct defects that you observe. What if you can't access the attic or the basement or the heating system? What is accessible and readily accessible? Well, we have that. We have, those terms are defined in the Home Inspection Standards of Practice, but we also have a glossary of home inspection terms. So let me type, for those of you live online, I'm typing nachi.glossary. Glossary. So it's nachi.org/ that's like us, that's where the question mark is, glossary. So if you go there and you enter the word accessible in the search, you get the definitions of what is accessible, what does that mean, and what is readily accessible. So accessible is, in the opinion of the home inspector, this thing that you're approaching can be approached or entered safely without difficulty, fear, or danger. So let's say, as an example, what if an attic, you see the access, you open up the access panel to the attic, unfinished attic above the second floor ceiling bedrooms, and there's no flooring. Well, that's not accessible. You can't enter it without danger, right? You need some flooring, and we'll talk about that later on in the webinar. Readily accessible means, well, it's accessible and you don't have anything obstructing your access to it. You don't have to remove something like a panel with screws or something like that, right? So you don't have to disengage anything that's connected and in your way. So when you say something is accessible or inaccessible or readily accessible, careful with your terminology. The words you use are really powerful, and they can get you in trouble, or they can make you sound amazing and very concise and clear and easy to understand. And InterNACHI has a glossary to help you with that. Every habitable room. So home inspectors, we often go into every room and see if there's a heating source. We use that terminology, right? Well, code, I'm going to refer to code. Don't be scared. We're not code inspectors, we're home inspectors, but we use a standard from which we can work from, right? That we all agree to. Code, we bump into code inspectors, local authority having jurisdiction, the township code inspector, the building inspector, the supervisor. We all talk about building practices, construction methods, standards by which a home is built. Well, we also have a standard of practice by which we perform an inspection. Well, it's kind of like our code, right? And code says in the International Residential Code 2018, section R30310, every house in certain climates and areas must have a heating system that maintains room temperature of at least 68 degrees Fahrenheit, 20 Celsius. But that's where it's cold. But not every location, like Southern Texas, Florida, it's hot and humid, right? So there's certain climates where that in the United States where you don't have to have a heating system. However, down in Florida, I've been down in Florida, just about every house has some heating, just in case. Climate is changing. Sometimes it gets cold in Miami, Florida. But during a home inspection, a lot of home inspectors will spend a little bit of time looking for a heat source in every room. However, it's impossible to do. It's impossible to do when it's occupied and there's furniture, carpeting, things like that, personal storage items, covering things, furniture. I mean, the register, the heating register, we're talking about furniture, so the heating register could be under a very heavy cabinet with dishes on it. You can't really tell, right? So we like to confirm every room has a heating source, but it's almost impossible to do. It is impossible to do during a home inspection. And that temperature of 68 degrees is the comfortable temperature, and it's supposed to be measured 3 feet above the floor and 2 feet above every exterior wall. And in every habitable room, which may include living spaces used for living, sleeping, eating, cooking, bathing, washing, and sanitation purposes. So if I'm doing a home inspection and I go into a bedroom closet, should it have a heating source? No. Let's say I go down to the basement and where I'm inspecting the furnace, say I'm in the basement, unfinished, and there's the furnace, there's a hot water tank, electrical, water and drainage. Should there be a heating source in that unfinished basement? Nope. Let's say there's this storage room off of the garage, and maybe it's off the laundry, and there's a door, and you go into the storage room, there's shelving, and it's 3 feet deep, 5 feet wide, and they use it for storage. Should there be a heating source in there? Nope. It's every habitable room. You got to be able to live in it. Live, sleep, eat, cook, bathe, wash, and sanitation purposes. Okay. Manufacturing code. Manufacturers' installation instructions and local building codes are wonderful resources. They describe the provisions and requirements of a properly installed heating system. You do not have to, during a home inspection, refer to code or refer to the manufacturer's installation recommendations. You don't have to even have it in your hand or refer to it in your inspection report. But it's a really interesting thing to learn from. So grab an installation manual. We have one right here. If you click it and open it, one of the cool things, it talks about every component of the heating system. And if you wanted to go to the most installation manuals have a startup section. So startup procedure, there it is. So there's a startup procedure, and this is written for the technician installing the system and starting it up for the first time or two or three, just to test the system. You can go through the startup process, see what an HVAC technician is required to do, their standard, to make sure that the heating system like this one, the Ream heating system behind me, how does it start up? What is the step-by-step process? And we used the manufacturing recommendations of several manufacturers and also code to help build this checklist that we're going over right now. And we also refer to the International Residential Code. And the International Residential Code related to gas furnaces and inspecting them and standards is chapter 24. And here's a book there. And in section G 2407, it talks about combustion, ventilation, and dilution air. And these aren't things that home inspectors actually inspect, but I thought it was interesting about what they mentioned about the what information can you get from code is really important to a home inspector if you really want to know comprehensively how to inspect a heating system. I'll show you. So the provisions in this section describe the requirements of combustion air that's necessary for the complete combustion of fuel gases, dilution of the flue gases, and the ventilation of gas-fired appliances and the space in which they are installed. An inadequate combustion air supply to gas appliances, gas-fired appliances, can comprise safety by causing incomplete combustion, resulting in a couple things, carbon monoxide. So we don't inspect those things, combustion, dilution, ventilation of the systems, but man, I'm often wondering about the abnormalities that I may see around the heating system itself and wondering, is this thing venting properly? Does it have enough combustion air? And what is the space around it? Is it safe or not? So if I was a code inspector, I would actually I'd be required to refer to the code book. But as a home inspector, I'm not required. But it makes me a better home inspector to know a few things from these resources, like using terms, confined space and unconfined space. turns out that the terms confined space and unconfined space and unusually tight construction of a house are no longer used in the code. The required room volume is determined by two methods. So if you have a furnace down in the basement or in a utility room, and it feels kind of small, usually they are. Sometimes they feel like they're in an unfinished closet, right? It's really small. I don't know why they install them in it's such an important, it's the lungs of the house, and yet they put it in a really small room. But the required room volume, how big should this room be in which the heating system is installed, is determined by two methods. One method based upon the actual air infiltration rate of the building, and that's where you need like a blower door. And the other is based upon the familiar fixed ratio of 50 cubic feet per 1,000 BTU per hour. So those are the two methods, and we don't go there at all to determine room volume in relation to the heating system and the BTU. Thank goodness, we'd be there all day doing that, right? So we're there to follow, we're required to do certain things according to home inspection standards of practice, but it may be good, may be beneficial for you to learn a little bit more than you need to know in order to perform a home inspection according to the standards of practice. Remember, the standards of practice is the absolute minimum that you're required to do, and it also lists things that you're not required to inspect. The combustion air and room volume is what you're not required to inspect. And you know, this is an example of why you may choose InterNACHI as your organization or school if you want to be a great home inspector and successful home inspection business operator. Because we're required, InterNACHI School is the only home inspector college accredited by the U.S. Department of Education to provide free training, education, business services to InterNACHI members. We're at internachi.edu. We're required to teach updated, current curriculum to our members. All other schools that are not accredited are not required. They're not required to teach you anything updated. They could be teaching you out of the same textbook that was written in the 90s by a failed author or school. As an accredited college, we are required to teach you the most updated current information. That's why I'm referring to these other resources, because we have experts in the industry that keep our curriculum updated so that you're never out on your own with old, unaccredited knowledge taught to you by some old instructor with old textbooks. So careful, not all schools are bad schools, I'm saying, but look for the good accredited schools. So if you want to check out InterNACHI's college accreditation, it's internachi.edu. And that's really, there's a lot of reasons to join InterNACHI, but those are two main things that come to mind. We provide the best training, education, continuing education for our InterNACHI members, and InterNACHI helps you save money because all the education is free through InterNACHI. All you got to do is join InterNACHI, and that's $49. $49 a month. So, and if you're interested in joining InterNACHI and you're not a member, I'll make you an offer. I'll give you a 50% discount on that. So all you got to do is email me, Ben at internachi.edu. Email me and ask me for that discount to join InterNACHI. Okay, unsafe. Is this thing safe or not? Well, unsafe is a really important term to use. So check to see if the system is safe to operate before you operate it. If it's determined that there's an unsafe condition, the home inspector should shut off the furnace at the electrical disconnect and advise the occupant or owner of the unsafe condition. Maybe the utility company may be needed. So one time I had a gas sniffer and I sniffed gas leak. You can smell it with your nose too. I shut it down, I did my best. The utility company came within 18 minutes. That was pretty good, that was pretty fast. And they tagged it and they figured it out as a bad old valve. What is unsafe? Well, the InterNACHI glossary defines unsafe for you. It's a condition of an area, system, component, procedure that is judged to be significant risk to injury to people during normal use. The risk may be due to damage, deterioration, improper installation, or a change in acceptable construction standards. So unsafe is used. I think of the space between the spindles, right? A lot of existing homes were built, a lot of the homes in the United States were built in the 80s and 90s according to code, but they had 6 inches of space between the spindles of a railing. Now it's 4, and that's unsafe. And what does that mean? Well, we defined it. Let's say you go to a heating system and you determine that it's unsafe in your opinion. Well, we actually wrote an article about your duty to warn the occupants. So let's say you're doing an inspection for a home buying client and you find a defect that in your opinion is hazardous. Someone could get seriously hurt. Do you have a duty to warn? Well, many inspectors consider it their ethical and moral duty to disclose to all relevant parties any imminent hazards they discover in the course of an inspection. In other systems, let's say I once inspected a deck that was attached to a townhouse, and I was underneath it, and the beam, the main load-bearing beam, was totally deteriorated. It was impossible to see because it was under capping, but I pulled the capping off a little bit. I went upstairs immediately and told everybody, don't go on the deck. Deck collapse is imminent. That means it shall fall. If you step on the deck, you will fall with the deck. So that was a hazardous situation. And it was taken well. I felt it was my duty to inform everybody. So if you go to a furnace system and you deem it to be unsafe, you may want to refer to the article that we have in our library of articles and take it upon yourself to warn folks. So if you go to nachi.org/articles, there you'll find other articles, including the duty to warn article. Remember we talked about exceeding and not exceeding? In that library of articles, we also have an article about to exceed or not to exceed, and that is the question. You may want to take a look at that as well. Because remember, the standards of practice is the absolute minimum that's required for a home inspector to do. But let's say you have, when in doubt, should you exceed or not exceed? And we recommend that you consider exceeding them when you're in doubt to benefit your client. Inoperable. Check to determine if the system is operable or not. If the furnace is not operating correctly, report it as in need of correction. You may look through a sight glass for a blinking light signaling an error code and document the code if applicable. Error codes or diagnostic indicator tables or a chart may be attached to the furnace. So in this furnace here, and for those of you who are listening to the podcast at nachi.org/podcast, you won't be able to see this, but I'm taking apart a furnace that we have. And let's see. There are 3 lights, little light bulbs right here on this panel board of electronics that we don't have to inspect, but I like to take a look at it just to see if there's anything missing, cracked, loose, pulled wires, melted wires, things like that. And there's some lights there. There isn't a viewing port in the panel, the blower door panel, but if there were, you could take a look at that, and the code blinks. And then there's a chart sometimes, not on this one, but sometimes there's a chart that will say if it blinks 3 times, that means that. But that's when it's unsafe or inoperable. You may want to go to that if you have extra time or not. Remember, a lot of the tasks that are listed in this checklist go way beyond the scope of a home inspection. So keep that in mind. So the sequence for operating a gas furnace like this one. When you see, if you're looking at the video or you're engaged in the webinar right now, if you're on the podcast, you won't be able to see the little bullets in the list of things to do. The step-by-step checklist is really a series of things to do, and they're bulleted. So the bullets are your check marks, right? So the first check mark, the first thing you do the first bullet point, the thermostat calls for heat. And then the draft inducer fan, that's this fella right here, that turns on. The pressure and limit switches check for problems, and we have one pressure, there's the diaphragm there, one pressure sensor, and we've got a temperature limit switch there. The hot surface igniter turns on and glows, or there's a spark that can tick, tick, tick. Looks like I've got a stick here, and it'll glow red hot. The power is sent to the gas valve, so the power going to the gas valve. Gas valve opens up, it activates. Gas goes through the manifold into the burner ports, shots here, and ignites. The flame sensor confirms that there's flame, so there's that little stick there. The flames heat the heat exchanger, which is here. The blower fan, which is here, turns on and circulates air through the heat exchanger. And a delta T is achieved, which is described on a label on the side of the unit here. It'll say, where is it? Air temperature rise, a minimum and a maximum. So that's the sequence of operation. Me personally, as a home inspector, what I do is, remember I do the roof, the exterior, I come in and I check for the thermostat in my mind. I'm gonna go in the dining room, that's where the thermostat location is. I go to the system, wherever it's located, in a utility closet, utility room, off the garage, or down in the basement. In my area, it was down in the basement in a cold climate. And I turn the service switch off. That's the first thing I do. And then I go back up. Well, I make sure it's safe and it looks, if it's in the winter time, right, you could touch the ductwork and you can feel that there's an operating system. Turn the system off with the shut off switch. Go upstairs, turn the thermostat on, call for heat. Go back downstairs to the system, turn the service switch on, and get ready. And I hunker down, I take the panels off, the front burner panel, leave the blower door on, and I get ready to watch the sequence that we just went over. And that's how I do it. So I turn the system off, call for thermostat. I go to the thermostat and call for heat, come back on, turn the unit on, and watch the sequence go through. And I don't heat up the entire house. If it's wintertime, it's already warm. If it's summertime, I'll turn it on momentarily, and I'll put that restriction in my inspection report, and then I'll turn it off. So it's safe. And then I'll pull the panel, the bottom panel, the blower door panel off, and then I'll take a look at the blower and the air filter and things like that. But the burner compartment door in this unit, which is louvered, I'll take that off so I can see inside. So that's the sequence of operation. Here's the checklist. So thermostat, look at the thermostat. In the inspection report, you're required to describe the thermostat location. Furnace description and location. Look at the furnace and its location. Describe the furnace's energy source and heating method. So for this one, this Ream unit, it's the energy source is natural gas. And the heating method, well, there's an air filter, there's an air blower, circulating fan. So we've got ductwork, that's the heating method. And report the heating method as in need of correction if it was deemed inaccessible, we defined that term earlier, and if it didn't operate or if it was unsafe. So check the accessibility of the system. Code is just crazy in some areas, especially when you're defined and when it tries to define like the pathway, passageway, and flooring width and opening dimensions, right? They're all messed up in my opinion. They're not congruent with each other. But the furnace must be accessible for inspecting, according to code and normal opinion. It has to be accessible for inspecting, servicing, and replacing with an unobstructed passageway and solid flooring at least 24 inches wide. If the furnace is located in the attic or underfloor crawl space, the passageway or opening should be at least, here we go, 30 inches high by 22 inches wide. 22 inches wide. Well, it just said it needed flooring 24 inches wide. And the flooring should be at least 24 inches wide and not more than 20 feet long. Well, so code is all messed up, in my opinion. They really should get this just right. So they're saying there's an opening passageway 22 inches wide, but the flooring needs to be 24 inches wide. Well, why don't they just make it 24 inches wide? And frankly, for me, that's not wide enough, right? And high enough. 30 inches high, 22 inches wide, I can't fit in there comfortably, right? I don't know if that's readily accessible. I'm 6'3", almost 250 pounds. I need something 30 inches wide, right? And about 4 feet tall. That would be really nice. That would be readily accessible in my opinion. But code, again, is we're not code inspectors, thank goodness, because that just doesn't make sense to me. As a home inspector, that would be really difficult for me to get through. Another example of code where code really doesn't make realistic conditions for us is the stairs and handrail, right? Code, can't remember where it is. Code says you need a handrail with 4 or more risers. 4 or more risers. What if my client is 80 years old? Or if my client has a physical challenge getting up steps? I'm not, as a home inspector, I'm not going to be on the side of my client in favor of my client. My client needs a handrail for 1 step. If there's 1 step, guess what I'm putting in my inspection report? And this is just me, it's not you. It's not a code inspector report. If there's 1 step, I'm going to side, my opinion is going to benefit my client. I'm going to side on my client's needs. And if there's 1 or 2 steps, I'm going to get a handrail recommendation. Obviously, I'm not a code inspector, I'm not an enforcement officer. A home inspector report cannot enforce anybody to do anything, can't force them to do anything. But I'm gonna put it in my report. So that's where I disagree with code. Code is 4 steps, forget it. That's too much. You need a handrail with 1 or 2 steps. Here, 22 inches wide, look at me. 22 inches wide, that's not wide enough. I think it's from a legacy code requirement when contractors, HVAC technicians, human beings were actually smaller. These little guys could go into an opening like that. I think we're a little bit bigger nowadays. Kind of funny. The location of the furnace must not be in a sleeping room, bathroom, storage closet, or in a space that opens only into such rooms or spaces. But there's always exceptions in code and standards. If the furnace is a direct vent furnace, or is a furnace installed in a room that meets certain volume criteria outlined in the building code, the furnace may be installed in a space that opens directly into a bedroom if there's a solid weather stripped door that has a self-closing device and the combustion air is taken directly from outside. And there are other exceptions and details. So careful. If you're inspecting a bedroom and you see a furnace, that's not good, right? If it's in a separate room and there's a nice weatherized, fireproof, steel, self-closing, weather-stripped door, right, then it's probably meeting code. You can probably put it in there. You can be hesitant. You're not a code inspector, but just careful. It's not automatic. There are a lot of exceptions to the rule about spaces and furnaces. Check the furnace category. Do you know the furnace category of the furnace that's behind me? And what do you mean by current category? Like if you take InterNACHI's free online training for inspecting HVAC systems, we have several courses online, free for members. At the end of the course, you'll have the knowledge and skills and abilities to be able to identify the energy efficiency of any heating system furnace from 10 feet away, right? Just by looking at it. This should pop to you. So I made some things. You may see some crazy stuff in this furnace just to trick you. There's some tricks here. But what do you think the category is on this one? Well, category 1 and 4 are often inspected by home inspectors, and category 1 furnaces operate with a negative vent pressure. They do not produce condensate. Scott, you're wrong. It's not high efficiency. They do not produce condensate, and their vent connector pipes are metal, type B. So Category 1, negative, no condensate, metal. Okay. Category 4 furnaces operate with a positive vent pressure, and they produce condensing flue gases, and their vent connector pipes are plastic, positive condensate plastic. And the plastic vent pipes for category 4 furnaces may be specified or furnished by the manufacturer. The common plastic combustion air and venting pipes are usually Schedule 40, PVC, CPVC, but the manufacturer's installation instructions will identify the required plastic pipe material. So actually, if you're taking a look at this Schedule 40 pipe, that's just a trick. So it's not supposed to be on this furnace. This is not a category 4 high efficiency condensate producing furnace. It's a category 1. It's supposed to have a metal vent pipe attached to the draft inducing fan. This is where the hot exhaust gases come out, right here. And it's supposed to be not plastic, but metal, okay? Because the exhaust gases are really hot here. On a category 4, the exhaust gases are not hot, really. And so therefore you could use a plastic vent pipe. And a category 4 plastic vent pipe, condensate producing, you wouldn't see these burners. You wouldn't be able to touch the burners, the ignition source, any of the elements inside. It would be enclosed. And you'd have fresh air intake for the burners. That's category 4. Usually 2 pipes. Category 4, high efficiency, burns most of the fuel. We're talking 90% or more efficient, very little wasted through the exhaust gases. So it's a really good system to install. It's expensive in the front end, but it should pay for your investment over the long term, the life of the unit. So category 4, plastic pipes. Category 1, metal pipe. Category 4, you can't touch the burners. It's enclosed. Category 1, you can touch the burners. Okay? Okay. So I'll put this back on. It's for fun. Screwing around with you guys. Category 4 furnaces operate with a positive vent pressure. They produce condensing flue gases. They're high efficiency. Their vent connector pipes are plastic. Okay. Type B connector pipes are made of metal. So this is Schedule 40 plastic. It shouldn't be here. This should be type B metal vent pipes. And they're designed for venting non-condensing gas appliances equipped with a draft hood, that's the old ones, or fan-assisted furnaces with a non-positive vent pressure. That's a negative vent pressure. The chimney is essentially like filled with hot air, and hot air rises, like natural gas furnaces, which are not made anymore. There's a hood that allows air to go into the vent hood through the chimney stack, and it just drifts up because hot air rises, and it's like buoyant. It's like a hot air balloon, right? And it's non-positive pressure, negative pressure. That's why it goes up, right? And to learn about furnaces and categories and efficiencies and vent connectors, take InternetG's free online How to Inspect HVAC Systems and go to the Identify and Describe section. Let's do that now. So there's the button to take the online course now. And there's the section about how to identify and describe in the 4 furnace categories. And there's a guy there in a video. And there's the 4 categories. There's category 1 here, category 4 here, right? And there's a nice illustration of a category 1 furnace, and we're talking low efficiency. It wastes a lot, like 30% of the fuel. So if you come across a natural draft furnace, that's low efficiency. So an older one would have that open draft hood that allows that dilution air to enter the vent pipe and mix with the exhaust gases. This is a category 1, newer. It has a draft inducer fan. It needs a metal vent pipe. The burners are open, right? So it's not high efficiency. Category 1. category 1 right here, mid efficiency. Now we're getting better with burning the fuels. Did I say low efficiency? We're getting better with burning the fuel. It wastes a little bit less fuel. It's a little bit more efficient. So mid efficiency, right? Category 1, metal vent pipe. You can touch the burners. Category 4, category 2, not common for homes, commercial furnaces really. Category 3 is really oil burners. Category 4 is the common heating system, high efficient, 90, high 90s, plastic vent pipe, enclosed burner chamber, fresh air intake, exhaust vent pipe, secondary heat exchanger inside, high efficiency. Yep. So let's go back to the checklist. Venting. Look at the furnace venting. According to the Home Inspection Standards of Practice, the home inspector is not required to inspect the interior of flues, chimneys, or vent connector pipes. But you could look at the exterior surfaces of the vent exhaust system, possibly the chimney liner, flue, inlet, exhaust vent, for signs of improper condensation. So on a non-condensing unit like this, we shouldn't see a lot of the watermarks and rust and white deposits left behind from condensing water in this unit. There shouldn't be a puddle of rust in the blower at the bottom of the blower fan, right? So there's something wrong if you see signs of water and condensate. So you can look at the surfaces for those kinds of signs: water corrosion, cracks, damages, blockages. And vent connector pipes connect the furnace to the vertical chimney or vent. So that's the vent connector pipe. This metal pipe, we call it the vent connector pipe. The common connector pipe for category 1 furnaces is type B double wall, and the metal pipe should be installed from the furnace to the termination. That's all metal. There shouldn't be any different kinds of material. No wood, no plastic. And vent pipes must not pass through any duct or furnace plenum. So what do you do as a home inspector? Well, here's your little checklist here. Look at the vent connector pipes for proper support and slope and termination. Plastic vent connector pipes must slope at least 1/4 inch per foot of run so that condensate drains back to the furnace. It doesn't drain out to the outside. It actually drains back to the furnace. It's sloped uphill from the furnace to the termination so that condensate, when it's produced, drains back to the furnace, collected and discharged outside in a controlled manner. So look at the outlet and inlet vent exhaust pipes and connections. They could be on the outside of the house, they could be on the roof. Look for secure fastening and support of the vent connector pipes. Support should be installed every 4 feet. No sags, no dips, no loose connections. Look for good glue. Look for insulation around plastic vent pipes that run through an unconditioned space where below freezing temperatures are expected. You're going to get a lot of installers and HVAC technicians and local authority and supervisors complaining about that. If you're in a cold climate attic and you have a high efficiency furnace with plastic exhaust pipes and they're not insulated, it's a good comment, at least a good discussion. So look at the exterior surfaces of vent and chimney connector pipes for rust, discoloration, loose connections, and signs of condensate. Look at the vent connector pipes for inadequate clearance from combustible materials. We'll take a look at that in detail a little bit more. Look at the exhaust transition connection between the draft inducer fan and the vent connector pipe, excuse me. So right here, a lot of manufacturer installation recommendations,
I didn't quite catch that.
Oops, say that this is really important right here. This connection is sometimes loose. And I tend to like tug on them now. I just give it a little tug and make sure that they're fastened and secured, because if it's open or it gets bumped or is loose or something like that, there's a lot going on right here. So apparently in the past, this connection has been poorly installed and poorly connected. So you need to get that. But take a look at that. Just look at it. Clearance. There should be a minimum 1 inch clearance. 25.4 millimeters of airspace, right, between the type B vent connector pipe and combustible materials. A single wall vent connector pipe requires 6 inches because it's hot, you can't even touch it. The building code and manufacturer's installation instructions will indicate the minimum clearances required between the furnace vent connector pipe and the combustible materials that are not protected. If a vent pipe passes through insulation, a metal shield is needed. So look at the gas vent pipe termination. This could be confusing for a lot of inspectors. Requirements for metal gas vent pipe terminations are described in the local building code. And gas vents 12 inches or less in size and 8 feet away from a wall must terminate at least a foot above the roof surface. So when you are walking on a roof and you have a gas-fired heating system and it's category 1, mid-efficiency, let's say like this fella, mid-efficiency, category 1, metal vent pipe, and you're looking at the height of the chimney stack, let's call it, of that gas appliance and the termination of it, and it looks really short. It looks only about a foot, maybe a foot and a half. It's probably okay. It's common, unless it's a high slope roof or some other exceptions and provisions, it's probably right. And it's unlike a masonry chimney stack of a fireplace. That's the 3-2-10 rule. This is different. The metal gas vent terminations for gas-fired systems like this are shorter, right? So if you have, and it's a big diameter pipe too, 12 inches or less, you need about a foot off the roof surface. They're going to be a little bit higher usually, I've found. So, and that's for a roof surface having a slope between flat and 612. So the steeper it is, the higher the pipe needs to be, right? But between flat and 612, which is very common slope for roofs in the United States, you're going to find a short little vent gas termination. Chimneys and gas vent pipes, where applicable, must have flashing installed, must terminate with a listed cap. Yep. For more information about fuel gas termination, take International's free online How to Inspect Fireplaces, Stoves, and Chimneys course and go to Chapter 3, Fuel Gas Termination section. So let's go there. There it is. Oh, I got it right there. So there's fuel gas termination. Fuel gas termination. It's a common mistake to apply the height requirements for chimney terminations per the 3-2-10 rule to fuel vents. So they're different. They're not the same, right? So there's the gas vent terminations. So this is from standards, this is from code. We try to teach you what the rules are so that you don't look, well, like foolish up on a roof, applying one rule for chimneys, masonry chimneys, to the vent termination for this appliance behind me. So protective barrier. Protective barriers must be installed if the furnace could be damaged by a moving vehicle. So you got those posts in the garage, right? Or any kind of barrier. A light and receptacle should be installed near the furnace. There should be a disconnect and emergency shut-off switch. I use the disconnect switch. The cabinet, as part of my inspection process, I turn the system off, sorry. Go to the thermostat, call for heat, come back on, remove the cabinet panel front, turn the service switch on, and look at the sequence of operation. An emergency shut-off switch may be installed at a distance far away enough from an unsafe condition at the furnace. And where I inspected, it was at the top of the basement stairs, and the furnace is down in the basement. Cabinet. Look at the cabinet fasteners, and cabinet panels. Look at the required clearance, combustion and service around the cabinet. The manufacturer's installation instructions will indicate the minimum clearances required between the furnace and the cabinet and unprotected combustible materials. In most cases, in general, there should be a clearance of at least 3 inches of working space around the cabinet. However, a lot of the code, the local code, or the manufacturing label will actually say 0. But that's just, for me, as a home inspector, it's kind of strange to snug a furnace cabinet right up against the wall, even if there's drywall and there's protection, right? A good 3-inch clearance is probably a best practice. But again, we're not code inspectors, thank goodness. So if you see in this checklist, we use a lot of look. And I'm starting to, this is a personal opinion, I'm starting to use the word look instead of inspect. Look has a better feel for what I'm trying to say in my inspection report. Look, the word look or looked, because I write in the past tense, I looked at this, I looked at that, is better than inspected. I inspected this, inspected that. Look at the thermostat, right? I looked at the thermostat. I didn't inspect it, which may convey, it may not, but it may convey in the mind and perspective of my client that I inspected it thoroughly by taking the unit off the wall, looking at the low voltage wires, the connections, taking it apart, look at the programming, looking at the efficiency of it, the accuracy of it. No. You know, a home inspection is a visual only inspection. It's like putting both hands tied behind your back and just looking around. So I like the word look. I like the word observe. I observed this, I observed that, but I also looked around. So you may want to think about the terminology that you use so that your client fully understands what you are doing during an inspection. You're looking at the gas furnace. You're looking at this, you're looking at that, right? Just a tip. So you can turn off the unit. This system doesn't have a switch on the side, but you can turn off the system if you wanted to and turn it back on. You can turn off the unit and then remove the panels, the burner compartment door, they call it a door or a panel front, gets you to the draft furnace and the switches and the manifold and the gas valve and the burners. And this one is to access the blower, obviously. Sometimes the air filter is here, and the emergency shut-off switch or the blower compartment air lock switch is right there. It's missing on this unit. Oh, here's the AFUE. So it's 80%. That's the efficiency of the unit. It's labeled right there. So look at the blower door airlock switch, which is a safety switch at the blower fan compartment right here. This one's disconnected for fun. Look at the blower housing, blower motor, fan blades, electrical wires. Look for dirt. So again, this is beyond, these tasks are beyond the standard, the home inspection standards of practice. You don't have to do this, but if you wanted to, you could. And the blower fan is there. There's no belt. Look for free rotation, minimum play of the blower fan. Look at the connection of the blower fan assembly to the blower compartment, right? It's usually hung at the top. Look at the main control board, the circuit board, which is typically located inside the blower fan compartment right there. Yep. And remember those error code light bulbs are right there. Look at the transformer, look at the wiring, looks good. Look at the electrical junction box, got it. Look, check and listen for the blower fan during operation. Look for and listen for unusual noise or excessive vibration. Gas shutoff valve, sediment trap, and piping. Look at the gas shutoff valve, which should be outside of the cabinet near the furnace. So it should be right here, right? And actually, I'm just teasing you. This pipe is for water. So it's for water use only. The valve should be accessible, located within the same room as the furnace, installed within 6 feet of the furnace, installed upstream of the union, connector, or disconnect device. So it should be right here. Look for a sediment trap or a drip leg, which is just below it. Should be installed downstream of the gas shutoff valve. So if the valve was right here, below it is the sediment trap, as close to the inlet of the furnace as possible. And it can be of any length. And what's a sediment trap? Well, we have an illustration gallery. If you wanted to spice up your inspection reports with really nice illustrations, here you go. Here's an illustration of a sediment trap. If your client is like, what's a sediment trap? It's this. So it's near the furnace. It's like a little leg that comes down. It's capped. It could be of any length. Usually it's only a few inches. And then the pipe, the hard pipe, no flexible pipe, comes from this T into the gas valve assembly here, which is then, this is the manifold and the in-shot burners. Yeah? Okay. Sorry if you're listening to the podcast of this, but we've got a furnace here and I'm just pointing at the actual components themselves. Look at the gas piping. The gas piping, there shouldn't be any flexible gas connector pipe installed inside the furnace cabinet. So if you see a flexible gas pipe installed in the furnace cabinet, which you will at the House of Horrors, that's a defect. The gas piping should be solid pipe. Only a hard metal pipe can pass through the furnace cabinet to connect with the gas valve assembly. There may be exceptions, but that's up to the local code. The gas flexible connector, if installed, cannot pass through the furnace cabinet. The gas flex connector must be completely visible in the same room with the furnace, the whole section. Look for CSST, the corrugated stainless steel tubing. Look for yellow jacketed or black jacketed. Yellow jacketed CSST is required to be electrically continuous and bonded to the electrical service grounding electrode system, or, where provided, the lightning protection grounding electrode system. So look for a bonding jumper when you have the yellow jacketed. That's connected to a metal pipe fitting, or the CSST fitting. The bonding jumper is 6 gauge or equivalent. The black jacketed is continuously, it must be electrically continuous and bonded to an effective ground fault current path. The black jacketed CSST is considered to be bonded, where it's connected to a furnace that's connected to an appliance grounding conductor of the circuit that supplies electricity to the furnace. Gas valve assembly, it's this one. So I removed the solid black pipe, gas pipe, right? And here's the gas assembly manifold. Look at the gas valve assembly, check the inlet operating, inlet gas operation during the thermostat sequence. So turn the unit on, go upstairs, call for heat, come back down, and you'll hear it click, right? And then you'll see it'll open up, the gas will go through the manifold, and it will ignite. If it's converted into liquefied propane, there should be a label. Inducer motor. Look at the inducer fan motor and blower assembly while it's operating. Natural draft furnaces are old and no longer manufactured. That's at category 1, inefficient, 60% efficiency furnaces. They're inefficient and beyond their service life expectancies. They're just no longer made. Pressure switches. Look at pressure switches and hoses. There may be more than one installed on the common 2-stage furnaces. So we've got one here. There's a diaphragm, pressure hose, and there's the hose connector into the draft inducer fan. Checking the pressure. Condensate. Look at the condensate trap for condensing units. Look at the condensate removal installation. Look at the condensate drainage pipe and traps. Category 4 appliances produce condensate. That's one of the distinguishing characteristics. Condensing furnaces should be provided with an auxiliary pan where damage may occur if the condensate drainage system fails. A pan is not necessary if the appliance has an automatic shutdown device installed. So I find those commonly in the attic spaces. Look at the condensate pump if one's installed. A condensate pump is connected to a furnace located in an uninhabitable space, such as if it's connected to a furnace in an uninhabitable space, such as an attic or crawl space. The furnace should be installed to turn off automatically if the pump fails. And the condensate pump should have an overflow shutoff capability. Burners and manifold. So there's the burners. This is the gas manifold. This is the gas valve assembly. Look at the burner assembly and manifold. In-shop burners are common. Yep. Look at the cover panel. Look for indications of water, corrosion, and blockage. Okay. Look at the air shutters, if present. Look at the burner ignition sequence during operation using a thermostat, a normal operating control. Look at the burners as they turn on and fire. Igniter and flame. Look at the igniter, the hot surface igniter or spark igniter, and associated wiring. Look for corrosion, cracks, and damage. So I have a hot surface igniter right there. Let's see, let's see, what if I change presenters? I'm gonna do something crazy. I hope I don't mess everything up. Let's see if this works. Are you ready? Okay, can you hear me? Hope you can hear me. So here's that pressure switch and the hose that's connected to the draft inducing fan. There's the gas valve assembly, right? And there's where we have that flexible water pipe coming in, but that's hard black pipe. This is the manifold that curls around to the burner ports. There's the igniter, hot surface igniter, right? This will glow red hot. And there's a sensor there. There's the rod, flame sensor. Let's see, it's right there. There's a temperature limit switch there, looking for flame rollout, essentially. It's right there. And the draft inducer fan. And there's that one concern about the connection between the vent pipe, metal pipe, and this area here. Oh, and we also have textbooks. So if you wanted to learn a little bit more about HVAC systems, we have a textbook from college. And fireplaces, stoves, and chimneys. There's a textbook, but here's the heat exchanger. Hope you all can see this. Hope this is working. So this is the heat exchanger. So right here, let's go back. So the burners are here, right? And it goes down in here, and it goes into the heat exchanger down there, which are very large pipes. You can't see them, but they're way down there. They curl up here, and they go into these smaller vent pipes, and they curl down, and they go into this one manifold here that's connected to the draft inducer fan. And it's an exhaust outside. Here's another switch here, a temperature switch. If this gets too hot, there's something wrong. And this switch is connected here, there, and it's connected to the electronics. It'll shut everything down if it's not safe. There's that fan switch. It's supposed to be there. There's a control board and little light bulbs indicating error codes. And there's a blower fan from below and from the side, and that's where the air filter would be located right here. So those are all the parts of this gas furnace. Okay, let's go back. Hope everybody got to see that. Did that work? I hope that worked for everybody. Okay, good, thanks. Sean, Keith, Jason, thank you very much. Okay, so igniter and flame. Did we go? No, we didn't go over that. So look at the igniter. We saw that before. Hot surface igniter is what is here. The flame sensor, which is that small metal rod that we showed you, it's called the flame rectification probe. I wouldn't use that in my report. Look at the flame rollout switches, which is that thing just above the flame recognition or rectification probe. Look for cracks at the hot surface igniter. You may see white spots when energized. Check for proper operation. Listen to the clicking at the spark igniter if installed. Look at the ignition source. The ignition source, which is this thing, should be at least 18 inches above a garage floor. And in relation to this provision, rooms or spaces that are not part of the living space of a house and are open to the garage are considered to be part of the garage. So that means, to me, you have to interpret code sometimes. If you're in a garage and like you're in a split level, you know how split levels are? So you're in a garage with an attached garage, and there's sometimes an access panel at the rear of the garage of a split level, and that access panel goes to an underfloor crawl space under the living room, right? Well, if that's open, that's essentially, code is saying that's part of the garage. If there's a furnace in there, an ignition source, it needs to be 18 inches above the floor. So if the way I see what this is saying is, if you're in an attached garage, right, in a split level, and there's an opening to a crawl space, underfloor crawl space, and there's a furnace in there, it can't be resting on the floor. It has to be 18 inches high. That's one of the things. We're not code inspectors, right? But knowing these standards just makes me a better inspector. And when I come out, I'm not going to kill the deal because I found a defect and I can refer to code. My clients fell in love with their dream home. There's hardly anything I could say to ruin this. It could be fixed, you know. You just block off the opening or raise the ignition source, right? So, and you want to look for an erratic flame or anomalies during the operation of the blower fan. I personally have never been able to attribute or diagnose with the help of an HVAC technician a moving flame with an obvious crack in the heat exchanger. So just be careful with that. Sometimes flames move. Limit switches. Look at the temperature limit switches and wires. We did right there. And then we saw the one above, right? So that's another one. Look at the electrical components and connections and wires. Everything looks pretty good. This is a very basic system. That's why we like it. Combustion air. We talked about this previously. We are not required, according to the Home Inspection Standards of Practice, not required to inspect combustion, ventilation, or dilution air. But again, INTERNACHI, an accredited home inspector college, we abide by national standards, just like all other actually accredited schools. And we're required to teach updated current curriculum. So that's why we went to the code book just for a moment and talked about those three things: combustion, ventilation, dilution air. Air for combustion, ventilation, dilution of flue gases for gas-fueled central furnaces and heating systems must be provided by certain provisions listed in the manufacturer's installation instructions, which we looked at before, and the local building code. Outdoor air may be introduced in accordance with one of those methods described in the code. Makeup air must be provided where clothes dryers and exhaust fans may interfere with the furnace's safe operation. I'm concerned with that when I go into a small laundry room, utility room, and I've got those three things. I've got a clothes dryer, an exhaust fan, right? With an exhaust fan. I have a hot water tank, and I have a furnace that needs air, like this fella, right? High efficiency, category 4, I'm not too concerned. But this one is drawing air for combustion, right in there. And it's competing with other things that are depleting combustion air. And in the code book, you won't find a lot of illustrations in the code book itself, but I found that the commentary, the code and commentary versions are really helpful because of these commentary figures in section G 2407.4. And there's a lot of things that compete with a gas-fired furnace like this one that needs combustion air from inside the house. I mean, there's a bath exhaust fan that could run 80 cubic feet per minute, a range hood in the kitchen that could run 100 cubic feet per minute, a fireplace, hundreds of cubic feet per minute. Clothes dryer, 150 cubic feet per minute. A boiler, a water heater, another bath exhaust fan. I mean, they're all depleting combustion air away from something that needs it in order to have safe operation. So interesting. So there's plenty of room to grow in your knowledge about furnaces. You're only required to follow the home inspection standards of practice, which is fairly simple and very easy to follow as a home inspector. But you may want to enjoy getting into the depths, the knowledge that you need in order to excel in your profession as a home inspector, and be able to, without referring to code directly or arguing with a code inspector or an HVAC technician, you can talk about intelligently about signs of condensate, which may be related to combustion air, and just leave it at that. Okay. Air distribution systems. Look for vibration isolators. That's that rubber stuff at the top of the furnace, between the furnace itself and the ductwork. Look for the air filter for dirt. Look at the air filter compartment, the access opening, and the air seal if it's installed like outside of the cabinet in the ductwork at the return. Sometimes those are completely open, and you don't want that, right? You don't want essentially a return register next to a furnace that needs combustion air. Look at the accessible ductwork for indications of moisture accumulation or biological growth, mold. Look at the accessible ductwork insulation, including exterior vapor retarders. Look for rips, tears, and damage. Look at the accessible ductwork support, duct strapping, hangers, sections, joints, and seams. Look for loose sections, open air leakage, failing duct tape or mastic. Ideally, all ducts at the seams would be sealed with mastic. That's that, it's like a thick, if you haven't seen it, it's like gray paint, really thick paint. You seal the seams. Look for material on the duct indicating possible asbestos material. It's a defect and hazard even if it's intact, appears intact. Return air for furnace should not be taken from a furnace room. Mentioned that before. An unconditioned attic, that's just in a cold climate, that's just insane. A closet, unnecessary. Bathroom, obvious reasons. Kitchen and garage. A garage could be hazardous. Look for a supply source or a duct register. Every habitable room, and we defined what a habitable room is before. Every habitable room should have a supply of conditioned air. Look at a representative number of grills, registers, diffusers, and dampers for dirt accumulation. I really enjoy when the air is distributed by ducts and I get a living room or bedroom register. I'll open up the register and stick my hand or camera down there, usually my hand first, and then take a picture of it. I usually find the original sawdust from when the house was built, nails, screws, and things like that. So for my clients who are sensitive to indoor air quality issues, that's a really good observation. We went over the sequence of operation, so we'll skip that. I think the last section in this checklist is a little information about airflow and delta T and how they're related. Airflow over the heat exchanger is very important. One of the most common causes of heat exchanger failure is overheating due to low airflow. Delta T, and this is way beyond the standards of practice again, but delta T is the temperature difference between the air supply and the return air. Delta T can be used to help diagnose system performance. Calculating delta T is complex and is beyond the scope of a home inspection. Calculating delta T at a forced air duct furnace involves an HVAC technician subtracting the return air temperature from the supply air temperature. And the difference is the delta T, or the difference in temperature. So delta T for a heating system may be indicated by the data plate on the furnace as the temperature rise minimum and maximum. And actually on this system, it's right over here on this plate, and there it is. It may be a 30-degree difference in temperature, and actually it is. Yep. If the delta T is too high, poor airflow may be the problem, right? If it's too hot, the airflow over the heat exchanger may be inadequate. If delta T is low, the furnace capacity may be inadequate, and there may be too much airflow. So, a little information about delta T and airflow. And that's the inspection checklist, but there are references that you may want to know about. There's the INTERNACHI Home Inspection Standards of Practice. So if you click that, you scroll down and you click the heating section right there, and you jump to the heating section. Nice and colorful. The 2018 International Residential Code, Chapter 24, is a really great resource for you, fuel gas. How to inspect fireplaces, stoves, and chimneys course. And it looks like that. And that's the certification logo, Chimney Inspector. How to inspect HVAC systems course. And there's our logo there. It's a free online training course. Inspecting HVAC energy efficiency for inspectors course. That's a free online course for INTERNACHI members. And it looks like that. Advanced HVAC training for inspectors course. Boy, we have a lot of courses on HVAC. It's really important. It's the, again, it's the lungs of it's the breathing lungs of the house. And we have a Healthy Homes Part 12 heating, air conditioning, and ventilation course. We have home inspection checklists for you to incorporate into your home inspection software. Earlier in the webinar, I showed you my software on my iPhone, how I incorporated a checklist into my software, and also the checklist, HVAC inspection procedure checklist, bulleted list as a reminder of what to inspect or not. But we have a ton of home inspection checklists. We have the basic home inspection checklist. I'm just scrolling down a web page for those of you listening to the podcast. Gas furnace inspection checklist. That's the one we just went over. We have a pool and spa inspection checklist, a California specific one. You can download it. There's a course that's related to that checklist. There's a radon mitigation and system inspection checklist. So if you're doing a home inspection and you bump up against a radon mitigation inspection, radon mitigation system, sorry, with a fan and the pipes, well, I would inspect it. Because oftentimes I will find a system or component that is just outdated. Like, we know better now how to install things. So if there was a missing catch pan underneath a hot water tank in an area where it could cause damage if it leaked, we know better now. When the house is built, didn't require that. Well, I'll put that recommendation in my report. That's one example. If the space between the spindles is large enough for a child to fall through, even though that handrail was built to code back then in the 19 whatever, it's a hazard now for small children. So I would put that in a report. If I bump up against a radon mitigation system, right, that was built 10 years ago, according to an old standard, I can inspect it according to this checklist, according to modern standards. So checklists are really important. There's a mold inspection checklist in standards of practice. There's a wood destroying organism inspection checklist. I really like that one because I inspect and report upon anything that destroys wood, even bugs. Now, in most states, they regulate pesticide applicators. I'm not spraying anything, but I'm a home inspector and I'm supposed to look at anything that destroys the structure of the house. And if it's a bug, I'm not an entomologist. I'm not gonna identify the termite type and bug itself. I'm just gonna say it's been eaten by something. Electrical inspection checklist. So if you're looking at a panel and you are inspecting the electrical panel board and you want a checklist, we have one of those. It's a step-by-step procedure to make sure that you inspect everything. INTERNACHI's Healthy Homes Inspection Checklist. If you want to be a certified Healthy Homes Inspector, we have that accredited training program and certification, and you can use the logo and the resource materials and the online course and the checklist. Aging in place inspection checklist, move-in certified, green certified, class 1, class 2, inspect, final walkthrough checklist, basic maintenance inspection checklist. If I were you, I'd be not only scheduling home inspections, right, for next week, but I'd be scheduling basic maintenance inspections for next year for every client. Now, not only are you scheduling next week, but you're scheduling next year's jobs too. A pet safety inspection checklist, and a ton of other. We've got a ton. We have everything that you need. And we have InterNACHI's free home inspection checklist software. So if you don't have software right now, we have a piece of software. You click that button there, and you go in, and you can do a report. So this is a report system that we use to confirm that you can perform an inspection and write an inspection report according to the standards of practice. It's a free software, very basic. I wouldn't use it for any client, especially a paying client, but I would certainly use it if you don't have any software. It works on any device. Inspect your home. If you're new, inspect your home 10 times using the software. Inspect a gas furnace 10 times using the software. Get really good and fast at inspecting, observing, documenting, checking, and making recommendations in your inspection report. And you can use the free software if you want. And that is the gas furnace inspection checklist webinar that we wanted to do today. I think I sucked up a little bit more than 1 hour. We scheduled it for 1 hour, but it went over. So if you are an InterNACHI member, you get 1.5 continuing education credit hours that you can upload into your education log and transcript manually by going into your online account and going to your dashboard. On the right side, I think it says CE records, and you can add credits that way. And that will help you comply with the CE policy that we have, 24 hours a year. But all of our courses are online and free to InterNACHI members. So feel free in being a member of InterNACHI and having free unlimited access to the best education you can get anywhere. That is the webinar. I see a lot of questions, and I don't think I'm going to be able to get to them during the webinar here. I've taken up more of your scheduled time, so I'm going to say goodbye and see if I can reply to the questions by email. So I want to thank you all for joining us at NACHI TV, NACHI.TV. Let me get there, because we have a couple other webinars coming up, which are really good. Click the registration button, and we have a ladder safety for home inspectors webinar coming up next week with American Ladder Institute. That should be a good one. So I'm Ben Gromicko from InterNACHI. This is NACHI TV, free webinars for home inspectors. Goodbye, everybody. Thanks for being here. I'll see you next time.